Hello, my name is Ikechukwu Obi. I am going to make a presentation on the design, fabrication, and testing of prototype microcontroller based power logger coupled to the hybrid photovoltaic thermal solar air heater. My co-researchers are Onwameze Kasmea Ileje, Chukwemeka Onyedema Anyoha, and Peter Anadebe Okonkwo. The aim of this work is to design, construct, and test the prototype microcontroller-based power logger coupled to the hybrid system. The objectives of this work are to measure the DC current and the DC voltage of the hybrid system, to measure the power and the energy of the hybrid system, and also to determine the power flow patterns as compared to the temperature flow patterns of the hybrid system. This data logger is an electronic device that records data over time. It is based on microcontroller. Typically, this data logger is small. It is a standalone power logger. It is battery powered and can also be powered by external sources. It is equipped with a microprocessor. It has memory for data storage, and it has sensors such as current sensors, voltage sensors, or you can say current sensor, voltage sensor, and temperature sensors. In this paper, we present a portable and rugged data acquisition module that is designed to monitor the power, voltage, and current, that is the load of the hybrid system. This power logger or power data logger could be used in monitoring the DC power flow patterns and the power surges of the hybrid system. It can also help in determining the electrical efficiency of this hybrid system. Most low-cost electric or power measuring devices are handheld and cannot measure power surges and power flow patterns, whereas some other power loggers are quite expensive. This particular data logger or power logger is a multi-point data logger, which means it measures current, voltage, and the temperatures, making it a multi-point data logging. In this way, we cannot say multi-point data logging is a method of automatic data capture using digital technologies such as advanced microprocessors, solid-state sensors, and fully featured software such as the Arduino software, which maximizes accuracy, in which values from a sensor like the current, voltage, temperature, and so on sensors are recorded and stored in a regular intervals. However, understanding of the temperature flow pattern in sympathy with current, voltage, and power flow pattern is also necessary in this work. We have some figures here. Figure 1 shows the power logger attached to the hybrid system. Figure 2 shows the power logger displaying these values of current, voltage, power, and temperature as well. And figure 3 is the schematic diagram of the whole system. Of course, this is the system, the hybrid system. This is the power logger here. And this is figure 1. Then figure 2, this is the power logger displaying the values of current, voltage, and temperatures, as well as power also, though the values are not indicated vividly here. So this is the schematic diagram of the whole system. That is figure 3. This is the hybrid PVT solar air heater. That is the hybrid system. This is the power logger. This is the charge controller controlling the flow of charge in the battery. Of course, this is the battery. This is the inverter that converts the DC current from this battery to AC current. Next slide is the materials and the methods. Of course, there are some materials that we used in the construction of this power logger. Arduino connection wires, of course, You know what that can be. Then Arduino Mega, of course, Arduino Mega, Arduino Mega 2560 is a microcontroller board based on Atmega 2560. It has 54 digital input output pins, of which 15 can be pulse width. I'll tell you that a microcontroller is a small computer on a single integrated circuit containing a processor core, memory, and programmable input-output peripherals. The important part of this microcontroller contains the processor, which all computers have, and the memory and some input-output pins that you can control. Yeah, that's the microcontroller for you, and the Arduino Mega 2560 is what we used. Then 15 of the pins can be used as pulse width output. Yeah, of course, the Arduino has the capability to output a digital signal that acts an analog signal. This signal is called the pulse width modulation. Okay. Then you can also put it this way, that pulse width modulation, or PWM, is a technique for getting analog results with digital means. Okay, so that's that, and so on about microcontroller. So we go down, of course, the PC board. The PC board, or PCB, is a non-conductive material with conductive lines printed or etched. Electronic components are mounted on the board, and the traces connect the components together to form a working circuit or assembly. That's PC board for you. Then go over to voltage regulator. The voltage regulator, of course, is a system designed to automatically maintain a constant voltage level. Of course, you have the one you can call 7808. Of course, is an 8-volt voltage regulator that restricts the voltage output to 8 volts and draws 8-volt regulated power supply to provide a convenient power source for most TTL. Okay, so, and that's that for you. Then, because the memory card, the buzzer is audio signaling device, variable resistor that reduce the of course it varies the value of the electrical resistance. SD card, of course, used in projects for transferring data. That's the module where we insert the SD card, and the FATA and the fan, the DC fan system. Of course, I've explained this voltage regulator. MAX 675 thermocouple amplifier is a temperature sensor. Then reset button, the device, that's the power logger. So of course, the data processing element is that it's a microcomputer. We already said. Then the block diagram of the data logger is this. Of course, you can see the microcontroller unit there. Then gray time clock attached to the microcontroller unit, the memory, the battery. Of course, the analog part is the measurement interface. Then you have port. Then you have the power logger software flowchart. Of course, when the logger starts, it initializes and checks the memory card. If it's bad, it buzzes. That's the audio signaling device buzzes. That's beeps or clicks, as the case may be. Then if it's good, then you check the RTC clock, that real-time clock, then check the card condition, then start printing into the memory card. That's generating the values of temperatures, current, voltage, and time. Then as well as power. If you compute power, that then stores the data in there. Then, of course, there are some specifications of some component used in the PVT hybrid system. That's you have the charge controller. These are the specifications for the charge controller. These are the specifications for the solar PV module. And these are the specifications for the inverter and the specification for the battery used. Then, of course, after generating the data, you have the results. The result is the data which is transformed into graph. In transforming into graph, you can see the behavior of the system, the PVT hybrid system. That's photovoltaic thermal solar air heater system, the PVT hybrid system. So you can see the red trend here is the power. You can see this one is the temperature, this one is the current. That leads us to say that in figure 7, because this is figure 7, as the temperature increased, power and current increased. The trend of power flow in watt depends on the trend of current flow in ampere, whereas the trend of current flow depends on the trend of temperature of the hybrid system. The flow patterns of current and power are the same. Of course, you can see it in figure 7. In figure 8, as the temperature kept increasing and fluctuating, current and power also assumed the same pattern. That's figure 8. Of course, figure 10. In figure 10, at the initial instance of the measurement, there was a tremendous increase of output power of the load due to normal operating temperatures of the solar PV module or the hybrid system or the hybrid PVT flat plate solar air heater module. So the output power decreased due to higher temperatures, justifying the fact that at higher temperatures, power output decreases. This shows that at certain operating module temperatures, current and output power increases in linear manner with insolation and temperature. Okay, you have that figure 11. In figure 11, at the beginning, temperature was not measured, and later, when the temperature was measured, the same trend was observed that current and output power of the load fluctuated with the module temperature. Yeah, the output power and the current, they fluctuated with temperature. You can see it there. In figure 12, finally, the low output power measured. You can see figure 12, it has a low output power, both current and power. The low output power measured was due to the type of load that was seen as if no load, though there is a load, but it's not so much significant. Still, it followed the same pattern as in the other figures, the same pattern of temperature. So, and at some point where the output power was tremendously high was due to the operating temperature that was almost at the reference temperature. Of course, that leads us to say that there is a cooling effect in this system, in this PVT hybrid system. There was a blower attached. So at that low, a very insignificant load, of course, there is this power surge showing the cooling effect. That's the result. Because in the conclusion, the data logger was designed, built, and tested. It showed good pictures of the load conditions being monitored. The power logger prototype was developed on a low-cost solution based on Atmega 2560 microcontroller. The reports facilitated by the power logger include the DC load power, DC load current, and DC load voltage. The total power consumption measured of the data logger on active state was about 6.944 watts. So for further development, the logger or power logger can be equipped with the ability to check maximum power point functions of the solar PV module, and also to measure alternating current of electrical systems or the PVT hybrid system, probably as the case may be. But in this case, we just measured the DC current, DC voltage, DC power of the hybrid system. Thank you.